Is a longtime member of our group and one of the organizers, and he's going to be talking about interactive graphics with Shiny and ggplot2.
And also base graphics a little bit. So I'm taking I'm coming at this issue from a slightly different angle than what Hadley was talking about it. Hadley was talking about interactive graphics in general, and I'm, for this problem that I'm going to be talking about, I'm going to be starting with Shiny and then getting interactive graphics to work with Shiny. So how many people here how many people here are familiar with Shiny? Okay, so that's most everybody, but not everybody. How many people have used a Shiny application before? Okay, so most everybody. And how many people have written a Shiny application before? Oh, wow, okay. That's a lot. Okay, so that's good. In Shiny, before we did this work to get Shiny and ggplot working together, the interactivity that Shiny gave you for graphics was kind of limited. So I'll demonstrate what it would be like. So this is this is the Hello Shiny example, the really basic one. Wow. Okay, and interactivity works in one direction. You have your sort of HTML form-like input. In this case, it's a slider. It's not exactly an HTML form thing, but but most of the inputs are something like this. And I'm controlling the number of bins in this histogram. And then that's an input. It gets sent to this R process that's running on my computer. And then the R process generates this plot and sends the plot to the browser for display. But the plot itself is just this static thing. I can't interact with it. If I try to click and drag on it, I'll just be able to drag the picture and maybe drag it onto my desktop or something. Not very exciting. So this is the state of interactivity with Shiny and base and ggplot2 graphics as of, I don't know, about 6 months ago. And let me show you what you can do now with Shiny and these plots. So first I'll show you how to interact with it. Oh, wow, this is really large. And then I'll show you some of the code. So this is a very, very basic example. This is a scatter plot of some boring data, empty cars. It's my go-to scatter plot data set. And then if you click on it, then right down here it shows the x and y coordinates. And these coordinates are not, they're not like pixel coordinates. They're scaled to the data coordinates. So the x is, on my last click, was 4.5, and the y was 24.1. So this is, so now you can interact with the graphics a little bit like this. And I'll show you the code for that. Help you understand how to actually use it. It's actually quite simple. So this is your typical Shiny application. There's for those of you that aren't familiar with this, there's two main parts. There's the UI code and there's the server code. In the UI code, you define a web page. The layout, you say it's a basic page. There's a plot output and a verbatim text output, and that was the text that was shown on the bottom. And the server code says you define the server code and you say output $plot1. That lines up with this plot output. And what that is it's a render plot, and then this is just base R plotting code. Plot, this x and y, these x and y values. And for the text, the verbatim text input, or output, which we called info, we have output $info here, and we say render text, and then we just essentially have it return a string here. So the parts that are different here from a regular Shiny app that just shows a plot are the plot output. It says click equals plot underscore click. And when you add that to your plot output, it defines an additional input, input $plot underscore click. And then you can access this from your server code. And this is a data structure which I'll show you in a little bit, but there's two really important values in it, x and y. And again, if I run it, let's try to make that bigger. So, if I click, it just gives me those x and y coordinates. Okay. It's also possible to do other operations, double-clicking, hovering, and brushing. And Hadley showed some brushing before, so you guys probably know what that means now. Let's see. Okay. So this time, instead of base graphics, this is ggplot2. And if I click on it, well, this is really huge again. This is the data structure that you get. So we'll scroll down and click here. So input plot$click. Can you guys read that in the back? Okay. It has the x and y positions. It's a list. It has the x and y positions. And then it has some other, some metadata that it contains information of like what the x and y variables are, the domain and range, which in this case, they refer to the domain is the data, the coordinates in the data space, and the range is the coordinates in pixel space. So it gives the dimensions of that gray, in this case, the gray plotting area, and other stuff like whether or not there's log scales, which in this case there aren't. So there's input $plot_click, plot double-click. So if I double-click, it'll give me, you can see that double-click position changing. There's also hover. So if I hover, that means if I just leave the cursor in one spot for, I think the default is like a quarter of a second, it'll update that plot_hover. And then brush. And if I move this brush, it gives you the xmin, xmax, and ymin and ymax. Okay, so if you're willing to, that's useful if you're willing to like dig into those data structures and use them for subsetting your code. But there's actually, there's some utility functions that make that easier. So, typically, here let's run that again. Okay, so if I got a scatter plot, if I click on a point, I probably want to do something with that. Or if I brush over some points, I probably want to do something to those points. And if all you have is the x and y coordinates, then you'd have to do that subsetting manually. But there's utility functions that make that easier. So those ones are called, just a sec here. So there's two functions that make that easier. So for a click type event, a click, double click, and hover, that's just a single point. You can just tell it to use the near points function. So you say near points, give me the data frame that was used in the plot. And then here's this, this is in this case, it's the last click, input $plot1click. And this will return the rows of the data frame that were near that click event. And let me show you that. Okay. Okay, so if I click here, the point, the last click is just that one point there. By default, the radius, it will select points that are within, I believe, a 5-pixel radius of that last click. So right now there's 2 points that are within that radius. One of them is the Valiant, and one of them is the Mercedes 280C. And also, as you can see, it's adding in the distance in pixels from that point to that click, the last click that I had. Okay, so that's all you need to do is say near points, give it the data frame, give it that plot click input, and it'll return those rows. And for brushing, it's very similar. You say brush points, give it the data, and then the input. And oops. Oh, I'm already running it. Okay, so then you can see those are the three. Well, these are the 3 points under the brush now, and there's a bunch of points under the brush now. And to show you the code, so in this slide, I just showed you the one line of code that does the work. If you're actually using it in a Shiny application, it'll be something like this. This is all, well, that's mostly comments, but I just said output $clock info, click info is render print, and then I just said use the near points, and that just returns a data frame which then gets printed out. And same with the brush info. It works the same way. Yeah.
So near points knows which values in your data frame are the X and the Y?
Yeah, so this input plot1 underscore click. So remember before there's that metadata that's being sent back, like it included the names of the X and Y variables. And yeah, so that's how it knows. And it knows that, so another little detail is that it can know the names of the X and Y variables for ggplot graphics, but not for base graphics. So with base graphics, you do have to supply the names of the columns that you want it to use there. Okay, so in these examples that I've shown you so far, where to go? These are like regular Shiny applications, which you deliver them over the web, and there's no, I mean, typically when you use these, there's no, the person isn't going to be using, it's not going to be interfacing with an interactive R session. So these aren't, like the things that I've shown you aren't necessarily useful for interactive data exploration when you want to do some interact with the graphics a little bit, and then and then do some R stuff, and then interact with the graphics. But that is also possible with Shiny, and this is a function that will make it possible. Basically, this function. It runs a Shiny application, and then when that Shiny application exits, it returns a useful data object. And actually, this is almost the same as what Hadley showed you earlier with using Shiny and ggplot2. Okay, so I won't go into the details about the content of this function right now, but if we run it, okay, let's see. Okay. So you already saw this, but I'll just show it to you. I opted to use a linear model instead of a Loess model for this. So if I can select those points and then remove them from the model, to remove them from the model, they're still there. They're still displayed there, but they're not black anymore. And if I just want to disable these points, I made it so you can click on them, and as you can see, the model line updates as I interact with those. And then when I'm all done, I can say done. And let's see the console again. So this particular Shiny application, when it exits, it returns a value. And in this case, the value is, it's an object that has, it's a list that has 2 components. One of them is selected, so it's a vector that indicates which rows of the data frame were selected. So these are, most of them, for most of the points it's true, but there's a few falses in here, as you can see. And so I could subset that data set, the original data frame, by saying mpg bracket $x$selected. If I run that, then this is the data that, these are the points that were selected. Or if I want to see the points that were excluded, I can just put the not operator there, and it gives me this about 9 rows there. Okay, now another, it also returns the linear model object itself. So So the model for the selected points, it gives you the coefficients there, the intercept and the slope, or you can run summary on that, and it'll give you some more information about it.
So that returns after the app is closed, returns to your last state of the app, if whatever was selected, not selected.
Right. So for this particular app. And yeah, this was, I mean, I feel like that, this app is something that, it's like the start of, well, it's maybe like one of the first of these little shiny applications that can run in the viewer down there in a useful way, in a way that's useful for interactive data analysis. So that's something that probably in the future we'll be expanding on and creating more little, I don't know what the right word is, but like widget types of things that will, that can allow for interactive data exploration. And that is it. So, are there any questions about this? Yeah.
So first of all, thank you. The question was, and maybe it's for Hadley as well, have you guys seen commercial applications of some of these things? Like, are companies small, mid-size, large, are they using some of these open source solutions for interactive data visualizations?
I mean, I know a lot of them use them internally, and they have things for clients and reports and stuff like that. I don't know if there's a lot of like public-facing stuff that uses these kinds of interactive graphics. I don't know. Hadley, do you?
I mean, the shiny stuff only came out a couple of months ago, so no one's using it really.
But that's the intent, right? I mean, the intent is to make this.
But I mean, a lot of I think a lot of people are currently using like Spotfire and Tableau to do this sort of interactive analysis, but they're really weak when it comes to modeling and data tying, all that kind of stuff. And I think people are starting to like put the pieces together about, how do you take the best parts of R for modeling and combine it with these nice interactive tools? I mean, there's going to be, I think there's going to be a lot of people will be using it.
Yeah.
So you showed that when the apps have over the other data at the end.
Yep.
Would it be possible to also just select some data, click a button, and spit it out to a sys or something like that? Select another set of data and keep doing it through the
Yeah, that should be no problem. I thought you were going to ask a harder question about making it work with an interactive while the R console is still available, and that is sort of possible, but it's complicated. But yeah, that should be doable. And I should mention one more thing. Those examples that I showed you, they're on the Shiny gallery and articles pages. So if you look at, if you go to if you go to like this is the articles site, the interactive plot stuff is at the bottom here. And same for the gallery. Just because it's the most recent thing that's been added, it's just is sort of at the bottom. But yeah, the examples there's a lot of code and a lot of explanation about how it all works.
I think this is also sort of a nice example. Can you show one of the brushes?
Yeah.
This is sort of like a nice example of what I mean by like hybrid computation, because when you brush the graphic, like when you draw that rectangle, that's just JavaScript drawing the rectangle. So it can do it very, very quickly, and it feels like instantaneous. And then it sends it back to R. So there's some computation that's happening in the browser, and there's some that's happening in the server, R, which hopefully kind of takes the best of both worlds. Like that's just drawing a rectangle on top of a ggplot2 plot. Like it's
this is if you're familiar with HTML, it's just a div that's semi-transparent, and that's why it's able to move so quickly, is because it's all happening on the client.
Can it show the model coefficients change when you use?
Yeah, I mean, you could if I were to, it would be possible to show another, like a text box at the bottom that shows the current model coefficients. That wouldn't be that difficult to add there. Yeah.
Could you interact in this way with a leaflet?
The leaflet stuff is completely separate, so yeah, no. I mean,
One thing we've talked a little bit about though is sort of having some, so all HTML widgets provides currently is basically the dependencies your widget needs to run. But we've also talked about maybe it should also provide some sort of standard interactive tools. So you could do like, you could brush a ggplot2 and it'll update a leaflet, or you brush a leaflet. So I think we're going to be working on that later in the year. But that's clearly would be really cool if you could start combining multiple widgets.
Along those lines, can you make multiple selections?
No, sorry. I
I
mean,
mean, you could.
well, I mean, I could implement that, but it would take a while. But
I mean, anything, you know, it's just, this was just implemented with R code plus JavaScript code. It would be very difficult for anyone other than Winston to do it because you also have to be familiar with the internals of ggplot2. But, you know, this is sort of a fairly general idea. If you're a really good JavaScript programmer, you can expose any of these sort of basic primitives to the other R users.
You could do it in each plot, and you have all the parameters of that rectangle. You can stack up the set of rectangles and say double click for dismissing those.
Yeah, you could do that. I mean, it's not hard. It's just like thinking about the right data structure to manage them, and how do you go back to the previous rectangle? So some interactive graphics packages provide you like the full suite of tools for interacting with a history of every rectangle you've ever drawn. And like that's too much, normally. So it's, you know, I think the problem is not like coding it up. The problem is thinking like how should it work to be maximally useful for people.
yeah, I mean, the goal for this was to be was pragmatic. You know, it's to get something that's the most people could get some use out of, and without going into ggviz complexity territory.
Hope for such interaction with the tabular display?
Well, you mean like dragging over rows and stuff? I mean, there's like the row selection stuff with the DT package now. I don't know the details of that because I didn't work on that stuff and I haven't really used it. Yeah.
I'm using iGraph for network visualization, and I'd love to be able to interact with these graphs. Is there anything you can tell me about
Oh.
how to accomplish this?
Network D3. There's a package called Network D3. D3 Network, maybe.
Okay.
And that basically gives you an interactive version of it. I mean, it works with much smaller graphs. It's the same.
You guys may not have this problem, but it's probably answered already, but just since you're here, what's the best recommended way for sharing this stuff with? So I'm probably the only R user in my work group, and I love doing this stuff, and it's great, so a meeting, I'm already imagining like pruning these things because I'm comparing two data sets, and kind of the sampling wasn't great, so kind of where you cut off the end of this time series has an effect, and it's cool to show people that, but then, I get requests like, oh, can you send me that? And it's
No. Because you're doing a mix of this, like you're doing this in R, like, and well, I guess you could do this interactively.
But I don't always have, the 3M. I don't know if we run I can't really run my own server, like leave my own computer running, and I can't upload it to. I'm cheap, so I only have a free account. So.
No, well.
Is there really a way where you can dump this somewhere? Is that on the horizon?
I mean, the solution is basically like how our studio as a company makes money. Commercial products. I mean, you either set up a server and run open source Shiny server yourself, or you pay us money.
Yeah. I mean, because at least for this stuff, it has to be running R somewhere. So, yeah.
I'm imagining like D3 where maybe I'm not familiar enough with it, but that pulls in the functionality, but you can have your data right in the
Yeah.
That's on the client.
The challenge is then you basically have to become another alternative is you also now learn how to do JavaScript. So you write everything in JavaScript. And put that in the static file, which, that's a legitimate solution.
Could you guys give a sales pitch for the publish feature that you have? I could probably use that in I
Oh.
don't have an account, but expensing that would be no problem.
So,
Let me
like,
see.
if you want, I think, like, to me, the like, one of the places where the commercial, like, the open source RStudio product, which is everything I do, and like a lot of what Winston does, and a lot of what we do as a company, is about, I think, making you as productive as possible as an individual. Like, that's what all of my packages make you really productive as an individual. If you now want to become sort of more productive as a team, or you want to integrate the outputs from your work and share them with the rest of your company, I think that's where our commercial products come in. So Shiny Server makes it very easy for you to distribute. So the goal of Shiny Server is so that anything you can see on your local RStudio server with a click of a button, you can publish to anyone who should be able to see that in your company. And not only that, but I think that in the next version, you also just say, well, I don't want to see them just today, but I want them to run every Friday morning at 9 a.m. and email all of these people in my company with the results. And then with like RStudio Server Pro, the goal is to make it as easy as possible to collaborate with the other people in your team. So rather than everyone working on their own computers, you work on a centralized server with centralized resources. The next version of RStudio Server Pro will have collaborative editing, so you can be editing the same R file at the same time. There's things like support for multiple versions of R. One thing that's really annoying at the moment, like for some projects, you want to use the latest version of R, so you get the latest version of your packages. But if you do that, and then every other project that you've worked on for the last 5 years now breaks because you haven't updated it, that's quite frustrating. So the idea is to help you also sort of insulate, so you can have projects that are isolated and keep working regardless of what else is going on. But those are the things that seem sort of most valuable from my perspective. And then there's also a whole lot of stuff. The other thing that the commercial products do is just sell to your IT department, like R is like a real programming language, and it has all of these things that you want, like logging, authentication, and monitoring. And hey, it's a real thing. It's not just a toy from statisticians.
Introduced a lot of things I'm familiar with and a lot of things I'm not familiar with. The future of R keeps changing. The landscape now is much more complex than it was. Where would you, if you're going to tell a graduate student or an undergraduate student, where would you have them spend their time? So which of the umpteen packages and ways of interactive graphical? I mean, what's going to be here? I'm asking you to a little bit play, future seer, but what's going to be here in a year or two and still be using and what's not?
I think in general, everything that can move to the web will move to the web. So as well as learning, the statistics side of things, learning a bit about HTML and JavaScript and how the web works, I think is really, really valuable. And then that sort of integrates in with the HTML widgets. That's the goal of our Markdown. I think all of that stuff is here to stay. That's going to be around in 10 years' time or 20 years' time, probably. And I think sort of tied into that, the way as a data scientist or a statistician you distribute your value, you show your value is not just by doing great analyses, it's by communicating the results of those analyses in the way that people can understand. And so, part of that's how do you make a cool shiny app that people can click? How do you make a cool 3D globe that people can spin around? But I think most of it is just much more basic. How can you write clearly? How can you explain complex ideas through a series of text and simple visualizations? I think that stuff is really, really valuable.
What about R and big data? So have you been working with Spark R and R Hadoop?
So we did. So Winston and another engineer at RStudio spent 2 weeks?
2 weeks, yep. Working with Spark R.
And so basically, the conclusion for right now is that Spark R is pretty awful to work with. It's incredibly frustrating to set up. And while like
I would still go so far as to say that I don't think I could use it for any real world projects at all. So
you'd go that far.
yeah, I think so. No, but that's not Spark. That's like the R interface to it, which is evolving very rapidly. So I think in the next version or two, it should be usable at least.
So my way broadly of thinking about big data problems is I think that there's, so first of all, if you're thinking about big data, that means data that can't fit in memory, and that is at least a terabyte now. So often people think they have big data because they have a gigabyte of data, and that is now like laughably small data. So, but I think if you do have big data, there are sort of three basic types of problems. So there are basically a lot of big data problems can be solved with the right small data. So often it's just a matter of getting the right subsample or the right subset or the right summary, so that while you might have terabytes and terabytes of data, you can, for most problems, you can answer them with a couple of megabytes or a gigabyte of data once you get the right data. And in that scenario, it's just all about R talking to the system where your data lives, allowing you to rapidly iterate to get the right small data set from your big data set. And I honestly believe that's like 90% of big data problems fall into that category. Once you've got the right small data, it's a small data problem. I think another set of problems is when you have lots and lots of small data problems. So maybe you want to fit a model to every one of your customers, and you've got 1 million customers. So fitting each model by itself is a small data problem. All the data fits in memory, but to do that for everything is really hard. That's sort of like what Hadoop is really good at, where you've got lots and lots of independent jobs. And I think that's maybe like another 9% of all big data problems. And then the last 1% is like legitimately big data problems where you do need all the data. Those are really, really, really hard, and they need like people with really good statistics and computer science skills to make any progress on them. So the way I sort of see it, that R fitting into that is that for R to survive, so R is never going to be good at big data by itself. But I don't think that's a problem, because to solve those problems, it needs to be good at talking to other systems, it needs to be good at talking to databases, and Hadoop and Spark, and I think we're seeing a lot of progress in that space. We also need some way to say, I've sort of figured out how to do this once on a small data set in my computer, now do that for every person or every location using a Hadoop cluster. And I think we're starting to see some, that's like the for-each package has tools for that. There's some basics of multi-core stuff built into base R. And then the final problem, I think that's going to be, we're going to see more products like database systems, but aimed more at analysis. And again, it's a matter of talking to those specialized tools. So I don't think people are going to be writing big data. People are not going to be solving big data problems purely in R, but to me, that's not a problem. Like what R is really, really good at is that rapid, fluid exploration of in-memory data. And you're still going to need to do that regardless of the size of your data. So, I think it's important to, like personally, so this is sort of my conclusions from trying to grapple with like, do we need to worry about big data? Is like big data going to eat all our lunch and R's just going to go away because it can only do small data? And my conclusion is no. Like there's still always going to be lots and lots of small data problems, which R is good at. And R is fundamentally like the vision of R from the very start. The vision of S was as this interface language that R doesn't have to do everything. It just has to be able to talk to the right people, the right other software tools, and R is really, really good at that. And I think, so for example, one of the things that I think of my work that's really cool is that the way that dplyr can work with remote databases. So you write R code exactly like you're working on a local data frame, dplyr translates that to SQL, sends it to the database does the computation. And as a language, R is really well designed for that. It's really well designed to do computing on the language so it can translate the things you express in idiomatic R into other languages.
Okay, thank you, Winston and Heather.